Okay, so let's have a look at the assignment. So this is the very popular mnist data set that you'll find everywhere on the internet as well. So we are going to work with CNNs today. Now for this mnist data set, you have a set of digits that is in grayscale and ranges from 0 to 9. You have to classify the digit, each and every digit. Okay, you have already done with the digits of Hindi Devanagari script. So this one is easy, but the CNN part, because you have not worked with it previously, so it's going to be a little bit different. Okay, so let's discuss the theory about this. So you have to implement a convolution model, number of filters, you have to change number of layers, size of filters, activation function, filter size combinations, layer filter combinations, striding, padding, and pooling. So striding, padding, pooling, all these things we have covered in the class, but just I'll give a quick review of what how to proceed with it. Okay, we'll just see how to proceed with it. So if somebody remembers, how do we start with in the convolution neural network, how do we start? So what is the first thing that is required to do? Of course, after reading that image, so let's look at the concepts first. Suppose I have image that is, because this mnist data set that I have, it is a grayscale image. So for a colored image, we have three channels, that is RGB. So if image is 28 cross 28, let's say, so it will be in 28 cross 28 cross 3. But in the mnist data set, it is a grayscale image. So it is size of each and every image is 28 cross 28 cross 1 basically. So it has only one channel, and this the values in this channel range from 0 to 255. That is why while normalizing, we basically divide it by 255. Okay, we'll see what we are going to do. So the idea is that each and every image is grayscale image, so it has only one channel. That is size would be 28 cross 28 cross 1 if number of pixels are 28 cross 28. So this is clear. Okay, so suppose I have this image. So what are the steps that we are following in convolution? First thing, we have to look at the convolution. Then we have to look at what do we do after convolution. We basically have a pooling layer. Then we have a fully connected layer, and then we have a output layer, that is maybe a softmax layer. Okay, so these are the steps that we do in a CNN. First is we perform convolution, then we have a pooling layer, then we have fully connected layers that can be 2, 3, 4 up to n number of fully connected layers. So this process, this convolution and pooling keeps on repeating multiple times. So this is called as layer 1, and this is called as layer 2, and this is called as layer 3. So what happens in a CNN? We have a convolution layer, con 1, then we have a pooling layer, pool 1. Okay, this is layer 1. Then we have, again, we can do multiple convolution layer, and then we can have a pooling layer. This is layer 2. Okay, then you have a we can do it up to n times. ठीक है. After that we have a fully connected layer. Fully connected layer is same. Fully connected layer is same as that we do in a neural network. Fully connected layer means all the if I have this fully connected layer 3, I'll call it layer 3 and this is layer 4. So all the neurons in the fully connected layer is connected to each and every neuron in the fully connected layer. So all the neurons over here is connected to all the neurons over here. Okay. And then we have output layer, which is a softmax layer. Output layer, which is a soft max, or maybe you can use sigmoid as well. Okay. So this is, now there's one more thing, because this is all image part. So here we also add a flattening part. So here is a flattening layer. We generally don't count this as a layer because we are just flattening the images that we have, representations that we have learned in layer 1 and layer 2. Okay, so again just recap that convolution plus pooling is layer 1, then convolution plus pooling is layer 2, and then we can repeat this multiple times. After that we have a flattening layer. Flattening layer is required because in previous layers we have image representations in the form of array, so we want to flatten it. Then we have a fully connected layer, which is over here. So we have a fully connected layer. Now this fully connected layer we can repeat it multiple times. Then this can be this fully size of this fully connected layer is basically output layer. So uh, last fully connected layer would be the number of outputs or number of class labels that you want. For example, you are learning a cat and a dog, so the last fully connected layer would be having one neuron. Okay. So last fully connected layer basically depicts the output layer. Okay. So this is then you have output layer, which is a softmax layer. You can also say that this is output layer with last with your classes basically. Okay. So this is the workflow in a CNN. Hmm. So we have discussed this in class as well. If you have any confusion about this, you can ask always. So let's see what are the things that we need to know in the convolution. So what is a, first of all, what is a convolution and why it is required? We have discussed this, that convolution is basically an operation in which we coincide an image with a filter, and that filter can be of smaller size than the image, and then that filter is required. Size of that filter is basically to learn the neighborhood values and to calculate the middle value, impact of neighborhood values on the middle value. So basically the neighborhood operation. So if my filter size is 5 cross 5, it's considering all the two neighbors in the left and two neighbors in the right, and so on. If my filter size is 3 cross 3, it is only counting the effect of its nearby pixels, that is one pixel in the left and one pixel in the right. I'll depict this with a diagram. Suppose this is my filter size and this is my image. So in a convolution, if this filter is a 3 cross 3 filter, so this means that it is only considering the, while calculating the middle pixel, it is only considering the left, this only one pixel from the left, one layer from the right, upper and down. So that only nearby pixels, effect of only nearby pixel is considered while calculating the middle value. Okay. So for calculating the convolution, convolution is an operation that is performed. First thing, we have to put coincide this filter over this image. So and then calculate the value. So because this is a grayscale image, so size of this image is 28 cross 28 only. So there is no cross 3. So it's not there. 3 is not there. So size is 28 cross 28. So we'll put this filter over here. So we will if we are coinciding this filter over here, we'll calculate the multiplication. This is A and this is B. So we'll do A into B plus C into D and so on. This way we calculate this middle value. So we will get the first number over here. Okay, so this way we are, so this value is A into B plus C into D plus up to all the 9 multiplications that uh, that are having, and then sum of that. So this value is, let's say, S, so we'll get S over here. Okay, then we have, so I'll write S over here. So what is the size? We have discussed this in class. Suppose if I have n cross n as input and f cross f is my filter size. So size of my output image is n minus f plus 2p by s minus 1 cross n minus f plus 2p by s minus 1. So this is the size of my output image. Now what is P and what is S? Can someone tell me what is P and what is S? P is padding and S is striding. We have discussed these concepts already, but still I'll give a quick recap. Okay, so padding is, there are two types of padding. One is no pad and second is same pad. So for same padding, what do we do? For no padding, we just have, if we have a 6x6 image and we have a 3x3 filter, so we get an output size of 4x4. So this means no padding. We are not at all padding. Next is, for same padding, we have 6x6 image and we have a 3x3 filter. So size of pad is, we apply A dash. For the original image, we apply padding and we get size of this padding is equals to f minus 1 by 2, that we have studied in the class. See, so f is, let's say, 3 minus 1 by 2, so that is 1. So I have to do padding for one cell. So the output, so after A dash would become 8x8. Why 8x8? Because I am padding one row. This was 6x6, and I'm adding this one column, one row above the 6x6 and one column in the left and one column in the right. So basically, one means in the upper part and in the lower part and in the left and in the right, in all the directions I'm adding 1 pixels simply. So the size of, after padding, size becomes 8x8. Now I apply 3x3 filter on this 8x8 and I will get a new image whose size is 6x6. So this is called same padding. Okay. Next concept was striding. Striding says that, suppose I have a image of, let's say, again 4x4, and my filter was, let's say, suppose, just an example, 2x2. Okay, so first I'll put, so if my stride by default is 1, what I'm doing is I'm putting my this filter over this position, and then I'm moving to right. So I'm starting, so my starting position is this position. I'm starting from this. Okay, so if my stride is 1, so my next position is this. So in next time what I'll do is I will, okay, if my stride is 1, it will be from this position. So my new calculation part would be over here. Then my new calculation would be from here, so it would be from this part. ठीक है. So this is my striding of 1, but if I'm doing striding of 2, so I'll do calculations leaving 2 pixels. So my first position would be this, and second position would be, I'll move 2 pixels to the right, so my next position for calculation would be this. Okay, so if I'm applying a padding of P, and if I'm applying a padding of S, striding of S, so my final output image size depends on that. So if my input is N cross N, filter is F cross F, padding is P, and then I have a striding of S, then so output image would always be, size of output image is always n plus 2p minus f by s minus 1 cross n plus 2p minus f by s plus minus 1. 1 minus 1 or plus 1? Let me check. So this is the final, what do you call, final output image size. Okay, so let me just confirm the formula is right or not. So it's plus 1. N plus 2p minus f by s plus 1, and this is plus 1. So this is the size. So suppose if I have a image size of, let's say, so we'll just look at the example. So you have already seen the Keras API, you have already seen that. So how does that work? So up till now, the whole scenario is clear or not? What we are doing, that is clear or not? I have got no response, so I'm assuming nothing is clear either, or either everything is clear. Okay, I'll repeat what I have said because you may find it a bit confusing. So we have discussed about convolution layer. So again, I'll draw this image. So because, so we have a convolution layer. In convolution layer, what do we do? First of all, we have n cross n image. We apply f cross f filter. We apply padding. We apply striding. We get image of size n plus 2p minus f uh, n plus 2p minus f by s plus 1 cross this same. Then we apply pooling. Now I have not discussed pooling over here. So in pooling, what do? We have seen in the class that in pooling layer, suppose I am applying max pool. So for max pool, what do? Max pool, in pooling, we generally take the size of pool as, suppose I have this image of 8 cross 8. Okay, and I have a filter of 2 cross 2. So in pooling, we generally we don't overlap the filter. So this is my first position, and this is my second position, this is my third position, and this is my fourth position. I'll draw it with another pen. So this is my first position for overlapping the filter. This is my second, and this is my third position. So in pooling, we don't overlap our filters. Okay. So what does max pool do? If I have a value of, let's say, 1, 2, 3, and 4, so this max pool will put 4 over here. So in my new image, so what would be my new image size? It is always 8 by 2, that is 4 cross 4, because in this whole uh, first part, from this whole first part, I am getting only one value, that is 4. ठीक है, that is the maximum value of the pool, whole pool. Similarly, for second part I can calculate and so on. So in max pooling layer we don't overlap our filter. We only just keep the same stride as the previous, as the size of the filter. Okay. So let's move on. Let's look at what is the, so we have applied pooling over here. Okay. So my input was n cross n. From here I have got n plus 2p minus f by s plus 1 size. Then I apply pooling. So if I am applying pooling, so it will just be divided by, so size of image over here would be n plus 2p minus f by s plus 1 divided by the size of filter. If filter was 2 cross 2, so divide by 2. If filter is 3 cross 3, divide by 3. Because we are not overlapping the filter, so it will just be the division of all the pixel values divided by the pixel value in the image divided by the filter. Okay. After that we have which layer, after we can repeat this is layer 1. Once we do pooling and once we do convolution, this is layer 1. Then we repeat this process. We can apply another convolution layer and another pooling layer. So we can say, okay, this is layer 2. Then we can apply any number of, let's say, fully connected layers. So fully connected layer is FC. This is layer 3. Then we can apply fully connected layer. This fully connected layer can be the output layer or the softmax, where we apply basically the activation function, which is for the output, that is softmax generally. Okay. So this is my FC, that is layer 4, and now I get the output. Okay. So this is the overall steps that you have to follow in the convolution neural network. Fine. So it's a little bit difficult to remember as well, and to implement as well, but it's not that difficult. Once you understood it, you'll find it quick and easy. Yes, there's one more thing. In the before the fully connected layer, here at this position, you also flatten your you have been flattening in the neural network as well. So same process would be followed here. You have to flatten your image, because it's of some n cross n size. So you are flattening it. Similarly, you are making it, basically you are making the 2 dimension or 3 dimension into 1 dimension. So whatever you have as input, you are just converting it into 1 dimension. Okay. Now let's come to coding part, because coding of this is also same as that you have been doing for neural network. What you have been doing for neural network, there are two ways. First thing that you are doing is you are just building a sequential model, and you are applying a flattened layer, you are applying dense layer, and so on. You are applying many layers in this, and then you are saying, okay, this is my sequential model, and I will do model.compile, and model.compile, I'll do that part later on. First thing, and second way that you will find over internet is you can either make this model equal to sequential, and you are doing model.add, and you are adding this let's say flattened layer, you are adding this dense layer, and so on. So one way is you can follow this or you can follow this. You'll find both of these on the internet, so both of the ways are correct. Now what is a sequential? So this is a sequential model that you can import from the from your Keras library, Keras API. That is, you have to perform from TensorFlow dot Keras dot model. You have to import sequential. So you are importing sequential model, and you are performing you are adding layers. So this part you have been doing already. This part you have been doing in your neural network already. You are just adding your dense layers in the model and so on. But here you have a different kind of layer. So only difference is you are adding a different kind of layer. So instead of only your layer part will change. So rest all the things would be the same. So from tensorflow.keras.layers, earlier what you were importing, so you are importing only dense layers, right? So here you will import. So what are the things that you need? So first you need a convolution layer, con 2D. Then you will be importing max pooling layer, max pooling 2D layer. Okay, dense, max pool, convolution, and what else? Flatten layer, flatten flatten layer. Only 4 types of layers are there in your CNN, so you will be importing all of these. So the only difference is you have to see what are the inputs that you are giving. So for convolution layer, we have seen what would be the inputs. So input would be this. I'll write with another pen. Okay. So what is the? There would be input image. Okay, image size, or what are the input? Padding would be the input, striding would be the input, and what else? You have activation function, that is ReLU in the middle layers, right? So for middle layers you have ReLU. Then what else? What are the parameters? You have filter. You have to give the filter size, right? Filter and filter size and number of filters. Okay, so it will be passed as a tensor. So input image, and that is number of image and its features, and filter, number of filters and the filter size. Okay, so these are the parameters for conv 2D layer. Now next layer is your max pooling layer. So for max pooling, what are the input, what are the sizes? For max pooling, you would be having the filter size, and from the filter size, you can easily decide the size of your uh, uh, output image. Okay. Then you have flattening layer. So in flattening layer, you just give your whatever the size of that is coming from the previous layer. So size of whole cube that is coming from the previous layer. Then you have a dense layer. So what do we give input in the dense layer? This part you know. So what do we give input over here? What are the inputs for the dense layer? Can anyone say this? No answers? Or you people are not getting anything? कुछ भी समझ में नहीं आया अभी तक. What are the input in the dense layer? Anybody? Or should I call out name? बोलो जल्दी से. Or everybody sleeping, or I am not audible, or anything.
आ गया
आ गया. तो डेंस लेयर में क्या होता है इनपुट? नंबर ऑफ न्यूरॉन्स. ठीक है, नंबर ऑफ न्यूरॉन्स, दैट इज साइज ऑफ द डेंस लेयर, और एक्टिवेशन फंक्शन. ठीक है. सो दिस इज योर द मॉडल दैट यू आर गोइंग टू डिज़ाइन. बस इतना ही था इसके अंदर कॉन्वोल्यूशन न्यूरल नेटवर्क के अंदर. सो दिस इज योर assignment that you have to work for. So you have to decide the number of filters, you have to change the number of layers, you have to change the number of layers. So that is your hidden layer, basically convolution layer. If you can put one convolution layer, so if you are putting this one convolution layer over, I would say this. So this is your one convolution layer complete. That is one layer, one convolution layer plus one pooling layer. Again, you have one convolution layer and one pooling layer. Okay. Then you can change the size of filters. You can change the activation function. You can change the combinations. Then striding, padding, and pooling. Okay. So this is your workflow. this whole uh, this whole part, this is your model building part. I will just show you code because it's completely new to you, so I will. Okay. So this mnist dataset is already built-in dataset in Keras. Some default datasets they provide, so you can just directly import this one. And this part you can do. I know completely that you can divide it into train set and test set. So you can see over here the size of training data is. So this is the number of images that you have. This is the 28 cross 28 is the number of pixels in each image, and one is the number of channel, because the data set looks something like this. So this is a grayscale image. So for a grayscale image you don't have a RGB channel, you have only one channel, so which is one over here. Okay. After that you have, so this is, and this is your output Y. Then so your output Y is, you are doing one hot encoding. So using the two categorical built-in function. So this categorical function is available with utils, keras.utils. So just encoding this and you are getting 10 classes. Uh, one had After one hot encoding you are getting 10 classes. So this is I'm printing test Y. So Y is encoded over here. Now let's have a look at the, also I'm normalizing. So after you are reading the data set, you have to normalize as well. So for normalization we use generally min max normalization. So what is the formula for min max normalization? uh, it says it's something like x is equals to, let's say x dash is equals to x minus min divided by max minus min into max dash minus min dash plus min, something like that. uh, Let me have a look at. Okay, so over here, so this is the formula. ठीक है. So v minus, so minus min a max minus, okay, I've written correctly. So this is min dash. So basically max dash is the max dash and min dash is the range that you want to convert it into. Suppose I want to make my range 0 to 1, and my original range was 0 to 255. So original range was of original min value was 0 and max value was 255. So I want to change this to 0 to 1. So 255 is basically converted to 0 to 1. Okay. So x dash is any pixel value that I want to convert. So x minus min is basically 0. Max minus min is 255 minus 0. Max dash minus min dash is 1 minus 0 plus min is 0. So that is basically x by 255. So simply whenever you see normalization for images, you just do x by 255. Okay. So first thing that you have to do is you have to read all the images. You have to do one hot encoding for the Y labels. Then you have to do normalization. You can do, or you, if you are not doing normalization, then also it will work fine. So that is optional part. So after normalization you will start building your model. Okay, model building that you have to perform. So these are the 4 things that you have to do. So for model building you have to do all these steps that I've explained previously. So over here, so normalization is done. So this is my model. So model equal to sequential, that I have uh, created this object. Then model dot add, first is my convolution layer, 32 cross 32, 32 cross 3 cross 3. So 3 cross 3 is basically the size of kernel size, that is my filter. Kernel size or filter size is the same thing. So somewhere you will find it as a named as kernel size, and somewhere you'll find this as filter size. Okay, so you have 3 cross 3 filter. Then input shape is 22 cross 28 cross 1, that is each and every image is of 28 pixels, and 1 is the channel. So this is the input shape, is always the size of the image that I'm giving. So note that all the images are of same size. Okay. Then now while building this model, we are not giving the whole data point yet. So we have not given the 60,000 points yet as input. We are just building the model. We are just creating the model. Okay. So for this, now max pooling 2D, this is 2 cross 2 is basically pool size. Pool size means the size of filter in the pooling layer. Okay, so if my image output in the previous layer was 10 cross 10, now my filter over here is 2 cross 2, so my new image would be 10 by 2, that is 5 cross 5. So after this I will get a 5 cross 5 image. Okay. So after that, this is a flatten layer. So flatten means we are converting this 5 cross 5 to flat. We are flattening it to a 1D form. Okay. After that, I'm adding one dense layer of 100 neurons, and output is dense layer of, this is my final output, dense layer, that is fully connected layer. So this is having 10 neurons. 10 neurons means it is having 10 classes, because we have 0 to 9 10 classes. So that is why my output layer is having 10 neurons. Okay. While compiling the model, you can use stochastic gradient descent, you can use any other gradient descent. I'm here using Adam optimizer. So model.compile, I'm using optimizer, that is Adam. Loss is categorical cross entropy. Categorical or binary you can use in case of sigmoid, but in case of softmax you have to use categorical. So what does softmax do? In softmax we have, suppose we have 10, we have, let's say this is my input, and we have some middle layer that is having, so all the nodes are interconnected. Then we have, let's say, two outputs, or let's say 3 neurons as output. Okay. So what does softmax function do? It gives me the probability. It gives me 0.2, it gives me 0.7, and it will give me 0.1. So the sum of all the probabilities is always 1. So what the softmax does is, so I'll take this one as my output. Suppose this is my cat and this is a dog, and let's say this is some tree. Okay, cat, dog, and tree. So I'm giving input of dog. So, and this is giving me 0.2, 0.7, 0.1. So I'll consider this one as my correct predicted output, which is having the maximum value, maximum probability. So this is my softmax function. So in case of softmax, we use categorical uh, entropy. ठीक है, तो we are using categorical cross entropy loss. Now this is, I have created this model. What you have to do is, this is my first layer, this is convolution and max pooling, this is my first layer. What you have to do, if you want to create another layer, you will just create like this. So you are adding just convolution, max pooling again, this would be your layer 2, and then you are flattening it, and then dense layer, multiple dense layers. Okay. So I have only created only first layer, one layer, one convolution layer. Now this is I am model dot fit. So some things are always the same. So model, whenever you are creating model equal to sequential, okay, this is always the case. You have to do this. Then you are model dot add, you are adding the multiple layers to the model. This will always be the same. Model dot compile will build your model. Okay, your model would now your model is ready to take input. Okay, model dot compile. After that you will do model dot fit. So this sequence is always the same. Whenever you are building a neural network, you are building a CNN, you are building RNN, whatever. Okay, this is always the same. So model dot fit is used to calculate the output, actual output. Okay, after that, uh, in model.fit you have to specify epochs, that you have to give the actual your data, your epochs, uh, to calculate the final output. Okay, after that you can do model.summary to show how does your model is working. Then you can print model.weights as well. Model.weights will give you the parameters, that is weights and biases, that is that are in the model. Then you can do model.predict for prediction on the test data. So these functions you have to remember always, because this workflow would always be the same, whatever model you are building, whatever. Okay. So first we have done model equal to sequential. We have added all the layers. We have compiled the model. After compiling, we have done model dot fit. Then we have evaluated the model for test accuracy. So I am getting 98.2% accuracy. This is model dot weights. So it's printing weights for all the layers that I have. Okay. So to check what is the input that your model is taking, so here model dot summary function is there. So model dot summary would it is saying that input is none, 26 cross 26 cross 32. None is because while building the model we are not giving 60,000 images as input. So none, if it is not none, it would be 60,000. 60,000 basically size, batch size that you are giving as input for the training. So if you are giving batch size of 32, so it would be 32. If you are giving batch size of 15, so none would replace by 15 and so on. Okay. So this is, so wherever this is none, this means you are just building the model without giving the training data as input yet. So, and the size of each and every image, you are specifying that it is 26 cross 26 cross 32. Then max pooling. So for max pooling size, that is 13 cross 13, because 26 is divided by 2. Your filter size was 2. In the pooling layer, you can see over here, your filter size was 2. So whatever is the size that is coming out of the previous layer, so it is divided by 2. This is 26 because you have specified some pooling, some striding. So original image would reduce to 26, and then it is divided by 2 because filter size was 2. Okay. After that you are flattening it. So if you multiply 13 cross 13 cross 32, you will get 5408. So this is your flattening. So you are basically flattening whatever is given as in whatever is the output from the previous layer. Okay. Then dense, first dense layer is having 100 neurons, second dense layer is having 10 neurons because you have 10 classes. So this is your complete model. Okay. Okay, so after that you are just, I'm just printing the loss. So over here, so if my loss is decreasing, model is working fine. Okay. And this loss I have, while doing model.fit, I have given 10 epochs and batch size is 32, and 32, and then validation data is test x test y. So what is validation data? Because we generally treat test data as a validation data, because we don't have actual test data for our models. So we basically test data, just understood that okay, test data is my validation data. So whatever is the output that it is giving, it's for test X and test Y. uh, how to explain this part? Suppose I have, let's say, what is validation basically? So suppose I have this model and this is my train data and this is my test data. So what does if I'm doing cross validation, basically this test is called as validation here, because test is actually the unseen data. Test is basically the unseen data that we don't have. So we divide the our data that we have into train and test, and this test is called the validation data. Okay. So you can also, you will find cross validation in some cross validation. So what is cross validation? In cross validation, you divide your data set into k subsets. So if my data set is, this is my test unseen data, so we are not talking about this test data, we are only talking about the data that we have. So we divide it into train and test, the data we have, and into k subset. Let's say if I am, so 5k 5 cross validation, so I am dividing it into 5 subsets. So I'll treat this first subset as train and then one as test, then again I will repeat for next, and I will do these next four as train and only this as test, and repeat. So for all the 5 combinations I will do that and take the average. So that is cross validation, k-fold cross validation. So if here it is 5 fold cross validation. So don't get into much detail, only just you have to check what are the inputs that you are giving to your model. Okay. So this is your overall assignment. I know it's a bit too much, but because you have already worked with a neural network, so it's not that difficult. Only thing that is changed is whatever layers that you are giving as input. Only thing. Okay. So that's it for today. Uh, Start working on your assignments. If anything is not clear to you, please let me know. Uh, And if you have any suggestions, anything that you want to share about deep learning or deep learning lab, you are most welcome to do that. So what we'll do is, in the last 15 to 20 minutes of this lab, you have to share a snapshot or whatever you are doing. Okay. Don't think like you have to do the whole assignment in the lab only. You have to just show whatever you are doing. You have to just either share a screenshot or share your screen or whatever. Okay. Click a picture of whatever you are doing and share it to me. Either this can be done, or you can share your screen, whatever. Okay. You have to show whatever you are doing, because this would be evaluated. There are marks for whatever you do in lab. Okay. There are marks, and please take it seriously. Even if you have written one line of code, even if you have do after understanding that code, write that code after you are understanding it. And even if you have understood one line of code, just share it. Okay. Show it to me whatever you are doing. Okay. If you have any questions, you can ask. And secondly, if you want to rejoin later, if you want to leave now and then rejoin and show your assignment, that you can do always. I'll download the attendance. Okay, I have downloaded the attendance. If you want to leave and then rejoin, you can do that. Okay.